All right. In the last video, you have seen four of these things like a variable, matrix, a string, and a cell array. Now, let's try to define these things a little bit systematically. We actually call them data type. Okay. A data type. Uh, let's give you some idea. For example, we have seen the integer data type at first. We have seen an integer data type like a single integer. Okay. Now, for example, 5 or 6, that is an integer data type. Next, we saw an array. Okay, more clear, more particular, numeric array. Okay, that contained only the numeric values like 5 or 6 or something like that. Okay, so that was our second. In the third, we saw another array that was a character array that we called string. Okay, in the fourth, we saw another type of array that was a cell array. Okay, now there are some other types of arrays as well. For example, another array and that we call a logical array. We'll see a little bit later. Let me just name those things first. Then there is another one, for example, say that is called categorical array. Okay, categorical array. Then we have tables. Okay, tables. Okay, and there are many others. Okay, there are some others. You don't have to know all of those things at first, only just to know the basic things. Okay, so for example, an integer. So integer is like, say, for example, 2 or say 4. That is my integer. Okay, this is an integer. A numeric array. For a numeric array, we are using a matrix, like we are using that we call a third bracket. Okay, uh, it is not actually the actual name, it is actually called square brackets. Okay, so in character, so we are using apostrophe or this quotation mark to define a character array, say, define a name or so on. In the cell array, we are using second bracket, or it is actually called a curly braces. Okay, this is actually called curly braces. Then the logical array is like, logical array is actually, it is true or false. Okay, logical array actually means, mm, sorry, is it true, mm, true or false? We'll see that a little bit later. Okay, now then we have categorical array and table. You don't have to know those things for now. So this is not actually not completely accurate, but to give you a very good idea to understand the difference, I have actually named those things. Let's go to matlab for now and take a look. Okay, let's go. So here I have all the values here. Okay, so for example, I can use this class. Okay, class is a function I'm using. These are what we call a built-in functions. Okay, we'll discuss these things later. So here you can see this k was the name, or l. So I have used this. You can see this is named as character. So this is actually a character array because our k was this. So I told you this is what we call a character array. Or for example, this m. Okay, again I type class of m. This is a cell, so this is actually a cell array. Okay, for this was your m, so this is actually a cell array. Okay, again if you use like y, this was my matrix, so if I use this class of y, okay, this was double. Now that is actually different. I will discuss those things later. The thing is, when I'm using this integer, there are actually different types of integers we can define: int 32, int 64, so on. You don't have to know all the details. The double that you actually saw here, okay, the double that you saw here, this is the default MATLAB integer data type. Okay, by default, just remember those things. This is also a numeric array, so that's okay, that's completely fine. Now another thing that is like, a was my 5 and b was 10, so a and b are not equal. So we can actually check these things, this double equal sign. We are using this single equal sign to actually assign. To use double equal, I want to check whether the left side and the right side are equal or not. So here you can see this is logical 0. By 0 means it is actually false. Okay, let's define another one. Say for example, b2 is equals to my 5. Then if I write a is equals to b, then sorry a is equals to b2, right? Then you have logical 1. Now this 1 means actually true. So here this logical array, this is true or false. For 1 means true or 0 means false, and it will be very useful later on. Okay, and other two things I don't want to show those things now. It will become a little bit complicated. And so far so far. So you have seen actually all of those things, and later on we'll actually practice some problems, okay, some exercise problems. This will actually become very clear to you when you actually practice lots of problems. But for now, just remember the names, so it will come again and again. Okay, now one other thing in particular I want to talk to you about. This is very important, so give a little concentration here. For example, I was defining a matrix like this, 7 8, say for example 7 8 4. Okay, this was our array, or you can say a matrix. Now and there is something very important to understand, that is called indexing. Okay, indexing. Let's make it black first. Let's make it black. Okay, okay, so indexing is something. This is I have three elements here. So the first element index is 1. Okay, in your C programming it was 0, but in MATLAB it is actually index is 1. So this is my 1. Okay, the second one is actually 2. Okay, this is my second matrix, second. This one is my 3. So this is what we call indexing. Okay, and this is very important to understand. So this indexing term, and this is in particular the one I actually showed you. This one in particular is called linear indexing. Okay, linear. Okay, and we'll see later on some other kinds. Okay, so for example, say our matrix was, let's define it again, 5 comma 5 comma 9 comma 55 comma 8. Okay, so I have 4 elements in this array. So now take a look. When I was defining the matrix, I was using third bracket, or say round brackets. But when I am accessing an element, want to see something, so this is what we call the first bracket, or the parenthesis, a of 1. So this is giving me my first element. So this was the index of the first element. So I can call all those elements by index. So a of 2 is equals to 9. Let's say a of 4. Okay, this was my 8. So this is what we call linear indexing. Okay, I remember these things, and we can use this linear indexing by using this parenthesis. So here when you are actually using linear index, okay, I'll be using this parenthesis. Okay, so remember these things. When I'm creating a matrix, that is my third bracket or round bracket. When I'm using cell, this is second bracket or curly braces. And when I'm using first linear indexing, we'll be using first bracket or parenthesis. Whenever I try to access some element from a matrix, I'll be using this. So let's define a matrix first. Okay, so for example, my x is equals to magic 4. Now don't worry about now what is this magic 4. We'll learn that later. So I have now total 16 elements. It is a 4 by 4 matrix now, right? So if I actually see x of 1, that is obviously 16. So what will be x of 2? This 2 or 5? If I access the second element, it actually giving me 5. So it is actually going through column wise. So if I use x of 4, it will give me 4. Then again if I use x of 5, then I have again this 2. Okay, so it is going column wise, 1 2 3 4, then 5 6 7 8 9 10 11 12 13 14 15 16. These are the index, linear index of these elements of this matrix. So say if I call x of 15, which one I'll get? Guess. I'll get this 12, because that is the 12th element. So this is what we call linear indexing. Okay, so this is for linear indexing for an array, also for a matrix. Okay, so let me write it down here so that it becomes clear later on. 8 9 7 7. Okay, let's use 0 comma 5. So I have this 2 by 2 matrix. Okay, let's use another one, comma 2 minus 6. Okay, I can use negative as well. So I have this 2 by 3 matrix. So okay, this is a 2 by 3 matrix. So this is my 8 is my 1, 0 is my 2, 9 is 3, 4 5 and 6. So this is my linear indexing. But in the matrix notation, you probably remember we actually use this term like 1 comma 2. Okay, this 1 comma 2, something like this. 1 comma 2 means first row second column, right? First row second column, this should give me this first row second column. If I use 1 comma 3, first row third column, or second row first column, 2 comma 1, 2 comma 2, 2 comma 3. So this is what we call subscripts. Okay, this is what we call linear indexing. This is another types of indexing that is called subscript. Okay, okay, the subscript is also another way to actually define this index position. Okay, and we can use these subscripts to access matrix elements as well. So let's take a look at my matlab. Sorry, or matlab. Here our matrix x was this. So if I want to this matrix, like say for example elephant, this is my x of 2 comma 2, second row, second column, I have elephant. Say I want this 15, so I have to go to fourth row and third column. So first the row number, next the column number. Okay, this is my 15. So this way we can actually access a particular elements of a matrix or a array. Now listen to the second term. I said we can access this indexing to array. Array means this all types of array. For example, if I say, for example, if I have a character array, say I have v is equals to Hermione. Okay, Hermione. Okay, now if I use v of 1, I get h. If I use v of 6, 5, I get I. So when I have a character array, I can also use this indexing. Okay, linear indexing. Okay, say for example, if I try v of 1 comma 4, I still get this because the fourth element is like this. But if I try v of 2 comma 4, then I get an error because this is a one dimensional array. There is no 2, there is not a second row. So always you have to understand the dimension as well. Okay, so any kind of array I can actually access this way. So if I define a cell array like this, cell array for example 8 comma 9 comma 3. Okay, now if I define x of 1, I get this 8. So in case of any type of array, I can use this indexing, this linear indexing or subscript to access a particular element in that array. Okay, I hope it is clear, and this is very important because indexing will be very useful later on. You will see when it comes to problem solving, indexing is actually the most useful, I would say. Okay, now another thing I would like to say before actually complete this video. So for example, z is equals to 7 comma 8. We are using this numerical array, right? Now say if I want to use something like 7 comma 8 comma, say I want to add a character in this array. Okay, what actually happens? It is not taking that, is it? If you look at this z here in this z, this is something like this. What is this? There is some problem, right? Yes, there is some problem because uh, I don't want to go to details for now because it is something related to the ASCII value. We'll see those things later. But for now, you can understand. For now, you can actually imagine like this way. Whenever you are creating like this, these are no longer a numerical data. If you actually do like this, if you use a string, so we actually tell this one. For example, this numeric array. Okay, this is what we call a homogeneous data type. Okay, this is what we call homogeneous. Homogeneous. Okay. This numeric array or this character array both are homogeneous data type, but another type is heterogeneous. Heterogeneous data type is the cell. For example, z equals to, if I write this cell 7 comma 8 comma v, now you can see you have all of those things elements, all of these elements separately. So that means when you are actually defining a cell array, it can actually contain a numeric value as well as a character. But when you are defining an array, it can contain either a numeric value or a character value, but not both at the same time. That's why it is called homogeneous. This is called homogeneous, only the same type of element. This cell array can contain both types. This is called heterogeneous. And here this table, okay, this category, this table and this cell, this both are okay heterogeneous data type. And this character array and this numeric array, these two are homogeneous data type. Okay, yeah, when you actually solve many problems, these things will actually become very clear. Okay, so far I believe you are actually clear with the basics. And there is one other thing about functions I want to introduce to you, and then we'll actually wrap these things up. Okay.